Hello everyone, my name is Sudheer Kumar, working as an assistant professor of mathematics, MLR Institute of Technology. In this lecture, I am going to cover the topic of change of variables in double integrals. Change of variables from Cartesian coordinates to polar coordinates. How to change the variables and evaluate the double integral, let us see. So, the procedure is, let us take x is equal to r cos theta and y is equal to r sin theta, and this dx into dy will become r dr d theta by the help of Jacobian. So this double integral of f of x comma y dx dy can be written as double integral over the region this d dash f of x means r cos theta, y means r sin theta, dx into dy will become r dr d theta. So here d is the region in plane corresponding to d dash is the plane corresponding to polar coordinates, that is r and theta, corresponding to the region in x and y plane, that is Cartesian plane. Let us evaluate this double integral using this example. Evaluate integral 0 to a, 0 to under root of a square minus x square, y into under root of x square plus y square dx dy by transforming into polar coordinates. The given double integral is in Cartesian coordinates. We have to transform into polar coordinates and then evaluate this. Let us take x is equal to r cos theta and y is equal to r sin theta. That implies dx dy will become r dr d theta. How this will become means with the help of Jacobian, that is not required as of now. So how to transform this is, first let us draw the curve. Here the limits for x and y limits are y is equal to 0 to y equal to under root of x a square minus x square. So this upper limit can be written as y square equal to a square minus x square. So this implies x square plus y square equal to a square. This is nothing but a circle equation. Of course, we are not bothered about total circle. This is x-axis, y-axis and origin. Since both the limits for x and y are having lower limit 0, that means the region is in first quadrant of this circle, right? So this radius is a, right? So this is theta equal to 0, this is theta equal to pi by 2. So the r limits are changing from 0 to a and the theta limits are changing from r equal to 0 to a, and theta varies from 0 to pi by 2. So this x equal to 0 to a and y equal to 0 to under root of a square minus x square, our x and y limits are transformed to r and theta limits. So this evaluation is transformed into polar coordinates in terms of r and theta, where r limits are 0 to a and theta limits are 0 to pi by 2. Suppose if the region of integration is in upper half of this circle, so theta varies from 0 to pi we can take. But here the region of integration is in only positive quadrant, that is first quadrant. Whenever the region is in first quadrant, we can see that theta limits varies from 0 to pi by 2. So r equal to 0 to a, theta equal to 0 to pi by 2. In this function, let us substitute x and y values. Y means r sin theta into under root of x square plus y square, that is r square cos square theta, plus y square means r square sin square theta, dx into dy means r dr d theta, right? So r equal to 0 to a, theta equal to 0 to pi by 2. R value this is r sin theta. If you take r square common, cos square theta plus sin square theta is 1. Under root of r square is, this total value is r. So r into r, we get r cube into sin theta dr d theta. So theta equal to 0 to pi by 2. Theta equal to 0 to pi by 2. What is integration of r cube dr? That is r power 4 by 4. Limits are 0 to a into sin theta d theta, right? So this can be written as integral theta equal to 0 to pi by 2. Substitute r equal to a, so a power 4 by 4 into sin theta d theta. So a power 4 by 4, take it common. Integration of sin theta is minus cos theta. So limits are 0 to pi by 2. So this is a power 4 by 4. Cos 90 is 0, minus cos 0 is 1. So minus of minus is 1. So we get a power 4 by 4. So this is how we evaluate double integral by changing into polar coordinates. Right, let us see one more example. By changing into polar coordinates, evaluate double integral of x square y square by x square plus y square. Where is the region over the annular region between the circles x square plus y square equal to a square and x square plus y square equal to b square. So the region is given between these two circles. Let us draw the region first. So a small circle. So this inner circle is x square plus y square equal to a square, because b is greater than a, that is given. The outer circle is x square plus y square equal to b square. This is x axis, this is y axis, right? So the region is in between these two circles. The region of integration is in between these two circles, annular region between these two circles. And this is the r limits between these two circles. So let us write x is equal to r cos theta and y is equal to r sin theta. That implies dx into dy will become r dr d theta. Now to transform this into polar coordinates, we require r and theta limits, right? Clearly r varies from, this is r, this limit is a, inner circle is having radius a, outer circle is having radius b. So this is b. So r is equal to a to b. We got r limits, and theta limits, we want to complete the between these two circles, we want the total area. So theta is 0 to 2 pi. So given integral can be written as r equal to a to b, theta equal to 0 to 2 pi, x square y square, x means r cos theta, that is x square means r square cos square theta, y square means r square sin square theta, by x square plus y square, r square cos square theta plus r square sin square theta. Dx into dy is r dr d theta. So this can be written as r equal to a to b, theta equal to 0 to 2 pi, r square into cos square theta, y means r square into sin square theta, r square, if you take it common, cos square theta plus sin square theta, denominator we get 1 into r dr d theta. So 1 r square is cancelled. So r equal to a to b, r square into r is r cube. This can be written as r equal to a to b r cube dr into theta equal to 0 to 2 pi sin square theta cos square theta, theta 0 to 2 pi cos square theta d theta. So integration of r cube is r power 4 by 4. Substitute the limits a to b, then integrate between the limit sin square theta cos square theta d theta. Theta is 0 to 2 pi. R power 4 by 4, in this substitute r equal to b, so we get b power 4 minus a power 4 by 4 into integral 0 to 2 pi sin square theta cos square theta d theta. So we get b power 4 minus a power 4 by 4 integral, this value already we have seen, we get, so b power 4 minus a power 4 by 16 integral 0 to 2 pi sin power m theta cos power n theta. This we can write it as integral 4 times of 0 to pi by 2 sin power 2 theta cos power 2 theta d theta, right? So this value, substitute this integral, so we get b power 4 minus a power 4 by 16. Thank you.